we started talking about 3D graphing, so I want to go back over that, make sure that we're still good on what we're doing with the 3D graphing. And then I want to get into solving 3x3 systems. There were two methods of solving 2x2 methods, right? Or 2x2 equations, right? We had elimination and substitution, right? Is there anybody in here who has a hatred for elimination? The one where you multiply and add? Okay, so then that's the one that we're going to be focusing on, because if I remember right, it was the easiest one for you. So make sure that you're taking good notes and following along. Substitution isn't really hard. It's just that because you have to isolate and substitute into the other two equations, it gets really big in a hurry. Because the whole idea behind solving a 3x3 is you change it into a 2x2 using either method. The path to get to a 2x2 from a 3x3 with the elimination is a lot shorter than it is with substitution. So if there's no complaints, I'll just show you one method and make sure we're good at it, right? Because if I remember right, most people were pretty comfortable with the elimination, right? So that's what we'll use. Graph the following point. So how would you graph this point on a 3D axis? So give me 1 minute here to get my scale set up. All right, so graphing in 3 dimensions. We have 3 axes, right? This is my x-axis, this is my y-axis, and this is my z-axis. Okay? Everybody all right? Yeah. So, 3-dimensional graphing. So this is your regular axis, right? X, y, right? So what we're doing is we're adding depth. So now you have an axis that looks like this. You have x, y, and z, right? But z points up. So z becomes your vertical axis, y becomes your horizontal axis, and x becomes the axis that gives you depth. Everybody all right? So z is up and down, x is left to right, or sorry, y is left to right. X is the one that gives you depth. How many dimensions is my board? 2, right? I can move left, right, up, down. Okay? How many dimensions is this? 3. Okay, so what I'm doing is I'm trying to make this appear on my board. So what we're doing is we're like taking this x-axis, right? So this is the one that's like gives you depth in both directions, and we're folding it down. So now it's only in 2 dimensions. Is my x-axis here, okay? So why is this dashed? Well, if this were even with the board and I added the depth, right, where does this go? Where's this section if I'm at the board? Through the wall, right? This is in Mr. Garcia's room right now. Okay, so how do I represent that? Well, in drafting, we use dashed lines to represent what are called hidden lines, things that are there but you can't see. So for the x-axis, it's solid here because that's the part that you can actually see that's coming off the board. Okay? And then the dashed line is the part of that axis that's running back through the wall. Okay? So that's why it's positive here and negative here. This is off the page toward you. This is through the wall into Garcia's room. Everybody all right with that? Yeah? All right, so what we're going to do is we're going to be using parallelograms. Okay, so first of all, what's a parallelogram? What's it look like? Okay, it's 4-sided, right? What qualities do you know? What do you know about a parallelogram? Okay, so opposite sides are parallel. I'll take that. And opposite sides are congruent, which means that they're equal. So we're going to be using that property over here to maintain equality. All right? So we graph in order. So which value is my x value? What's my x coordinate up here? 3. So I'm going to go to 3 on my x-axis. Everybody okay with that? Yes or no? The x-axis is still passing through the origin, correct? Okay, so what we're going to do is we're going to use the parallelogram in order to figure out where 4 units actually is. So what I'm going to do is I'm going to use a dashed line here, and I want it parallel to my x-axis. All right, so what was my y-coordinate again? 4. All right, so this line, the red line, is parallel to my x-axis, correct? So that means that if this is, what's the distance between the x-axis and the red line on the y-axis? So like, what's the distance from here to here? How many units? From 0 to here. 4, okay. So what that means is that any distance between my x-axis and my red line is how far? 4 units. Is everybody okay with that? So I'm using the parallel line just to act as a spacer, okay? And why I want it parallel to the x-axis is so that way they stay equidistant from each other. Because remember, I have to take this point that's at 3, and I have to move it 4 units to the right. Well, is that going to be where this 4 units is? No, because the angle that the x-axis is built on, right? So I have to mimic that. It'd be like if I said I'm going to stay equidistant to Jordan, and this is how far we're staying apart, right? I'm fine until you do what? Okay, you move, right? If you stand up and start moving, what do I have to do? Right, but not just however, right? If he stands up and starts walking to the door, do I get to walk to the left? No, I have to move on a parallel track to you, right? So what I'm doing is I'm building that parallel track. So I know any point on this red line is going to be 4 units to the right of the x-axis because that's my y-coordinate. Everybody okay with that idea? Yes, no, maybe? So it's like I'm making 3 distinct moves. I move down the x, and then I have to move either left or right for my y. So what I'm going to do is I'm going to draw on a horizontal line here. So this is where I was. That's 3 units on my x, and I move 4 units to the right. So that's going to be this point right here. Everybody okay with how I found that? Yes, no, maybe? Okay, so yep, I went 3 units on my x-axis positive, and then I had to move 4 units to the right, 4 units on my y. But because the perception of this is off because it's not straight anymore, it's on an angle, I'm using the red dashed line to tell me what does 4 units to the right actually look like. Okay, so because I made this red line parallel to the x-axis, the distance from origin to red line is going to be the same as the distance from x-axis to red line anywhere on the graph. Is everybody okay with the x and y? This red line is only there because it's parallel to the x-axis and being used as a spacer. Okay, now that I know how far away my point is, I could get rid of this. Okay, you want me to show you another way of doing it? Okay. It might be easier to understand what's going on. What's my y-coordinate? What's my y distance? 4 units, right? Everybody okay with that? So I have to move 4 units down my y. So let me pick a line that'll actually show up. Green should be different enough. There we go. So what's the length of this line? 4 units, right, in my y direction. So what I'm doing is I'm taking this distance and I'm sliding it down 1 unit on the x, 2 units on the x, 3 units on the x. Everybody all right? So the distance from 0 to my y-coordinate is the same from the axis as it is to where my x value is actually getting placed. So that's how I know how far away from the axis 4 units on the y actually is. And then I'm going to do the same thing with z. How am I moving on my z? Up 2. So I'm going to start at 0, move up 2 units, grab my spacer, move it here, and my final resting place will be at the end of it. That is actually where 342 is located. So we moved 3 units down the x, 4 units to the right on my y, and then up 2. Like the parallel line and the green line are the same thing. You need to come up with a way of spacing. So we move the same exact way, x, y, z. So we still move in alphabetical order. All right? Okay. So tell whether the ordered triple is a solution to the system. What does it mean to be a solution to a system? How many parts of the system must you satisfy? All parts. What does it mean to satisfy a part of a system? What does that mean mathematically? What do you mean by it equals? So what do I do? Like, what's my process, I guess, is what I'm driving at. Like, if I asked you, determine if this point is a solution to this equation, what does that mean? What would you do? Okay, you plug in your x, y, z, and then you want something true out, right? Okay, so I have to check and see if that point is true for which part of this system? All 3 parts. So, substitute. So what's my x-coordinate? -5 plus 4 times my y is 1, and my z is 0. And I want to know, is this true? Okay? So it seems out, let me change this background to white, see if that's better for the green. So what's 3 times -5? Negative 15. What's 4 times 1? Negative 2 times 0. All right, so what's negative 15 plus 4? So is negative 11 equal to negative 11? Okay, so far we're good, right? But does that mean that I'm done? Okay, I got to do it for every other part too. So okay, what's negative 5? Well, negative 5 is just negative 5. What is 4 times 1? And what is 3 times 0? And what is negative 5 plus 4? Plus 0. So is negative 1 equal to negative 1? All right, so far we're doing good, but we still have to check out this guy, right? Same thing, plug in what you know. Okay, 2 times negative 5 is? Negative 10 plus 1 minus 0 equals 11, and I want to know if that's a true statement. So it's negative 10 plus 1 minus 0. Negative 9. Is negative 9 equal to 11? No, so I put a slash through the equal sign, and I have to still answer the question. Is that ordered triple a solution to the system? Okay, so I put down not a solution. Or no, ordered triple is not a solution, something along those lines. Everybody good with that, yeah? All right. Okay, now on to the fun stuff. Solving a 3x3 system. This is a multi-step process, so please stay with me as best as you can. What we're going to do is the very first thing we do is we split apart the system in a very specific way. Okay, I put equation 1 and equation 2 together, and equation 2 and equation 3 together. Because if you think about it, if something is a solution to the system, that means that equation 1 and equation 2 have to coexist there, right? And equation 2 and equation 3 have to coexist there, and it should be the same point. Everybody okay with that, yeah? So that's why I'm breaking it apart this way. So I take my top equation, as is, no changes, and I take my middle equation and I put them together into their own system. Everybody okay with that? And then for this part, we take the middle and the bottom and form a system with those. So down here, I'll get 2x minus 3y plus 5z equals negative 14, and 6x minus y plus 4z equals negative 1. Everybody kind of okay so far? Okay? I mean, I haven't done anything major, right? But what's important here is that when you split these apart, you split them apart the right way. Equation 1 and 2, equation 2 and 3. Okay, now this is where we get a little, it's not tricky or hard, it's just you got to be particular. All right? Which variable do you want to isolate, or sorry, let me try that again. Which variable do you want to remove from the first system? X. Okay. So I'm going to use the elimination up here, right? I have a 4x and a 2x. What's the least common multiple between 4 and 2? 4. So what do I multiply with 4 to get 4? What do I multiply with 2 to get 4? 2, right? 1 times 4, is that a positive or a negative? 2 times 2, is that positive or negative? Can a positive and a positive add to become a 0? No, so what do I have to do? Okay, doesn't matter which one? Okay. Everybody okay, right? Just elimination. So now distribute 4x plus 2y plus 3z equals 1. On top, on bottom, you'll get negative 4x plus 6y minus 10z equals positive 28. And then what do we do with these two new equations? We add them together. So what's 4x take away 4x? What's 2y plus 6y? What's 3z take away 10z? Negative 7z. And what's 1 plus 28? Everybody okay? Yes or no? Okay, now how many variables do I have in this equation right here? 2. Okay, so we've taken a 3x3, we break it apart into two 2x3 systems, right? We removed x here, so what do you think I'm going to remove from here? X. And if I get a yz equation out of here, what am I going to get out of here? A yz equation, and I'm going to put it back together and have a 2x2 system. Can you guys solve a 2x2 system? Yeah, it's what we did in 3.2.
So I'm taking something we don't know how to solve, making it bigger doing math, and then simplifying to get rid of something so it is something we know how to do. Okay, so all we're going to do is the elimination 3 times. Everybody all right? Okay. So over here to the bottom equation set, to this bottom system, which equation did I remove from this system? X. So which equation do I have to remove from this system? X. What's the least common multiple between 2 and 6? So I get a 1 on the bottom, a 3 on top. Positives don't work, so I'm going to put a negative on the 3. Everybody all right? Okay, so distribute. And we're going to get negative 6x plus 9y minus 15z equals positive 42. Right? 4 times 3 is 12. 3, yeah. 1 on the bottom means I just rewrite the statement. And then again, what do we do with these? We add them. So what's negative 6x plus 6x? Cancel. What's 9y? Take away a y. What's 15z plus 4z? Negative 11z. And what's 42? Take away 1. 41. So you see here, I have one equation that has y and z in it only. Here, what are my 2 variables? Y and z only. So what I'm going to do is I'm going to put these 2 answers, these 2 red equations, back together as its own system. So I'm going to have 8y minus 7z equal to 29 as one equation in the system. And I'm going to have 8y minus 11z equals 41 as the other equation in the system. Everybody all right so far? Okay, so now I'm just going to solve this system. So if I gave this to you and said solve this system using elimination, what variable am I going to get rid of first, y or z? Y. Okay. So what is the least common multiple between 8 and 8? 8. So what am I going to multiply by here? Here. And one of these needs to be negative. So you get negative 8y plus 7z equals negative 29 on top, and 8y minus 11z equals 41 on bottom. You're going to add, what's negative 8y plus 8y? 7z, take away 11z, negative 4z, negative 29 plus 41. So that's actually 41 take away 29, right? So that would be, so how do you get z by itself now? So what's z equal to? Negative 3, so there's one answer. How many variables can I solve for at any time? 1, right? So can I plug that z back into one of the original equations and get an answer? No, because they have 3 variables and I only know 1, right? But do I have a system of equations where there's 2 variables only? Yeah. So I'm going to take the z and plug it into one of these 2, because there's only 2 variables and one of them z, so I know it, right? So which one do you want me to use, top or bottom? Top. So I'm going to get 8y minus 7 times negative 3 equals 29. 8y plus 21 equals 29. 8y equals 8. Y equals 1. Everybody okay with how I found y? So now, how many answers do I know? How many variables have I solved for? 2. So I have to go to where I have 3 so I can find the missing one, right? So what am I going to do with y and z? Plug them back into where? Right, one of the originals. Doesn't matter which one. Okay, so let me get rid of this. And which original do you want me to use? Top, middle, or bottom? Top. Okay, so I get 4x plus 2 times what's my y? Plus 3 times what's my z? Negative 3. So I get 4x plus 2 minus 9 equals 1, right? What's 2 minus 9? Negative 7. So 4x minus 7 equals 1. How do I get x by itself? Add 7. So 4x is equal to 8. So what's x equal to? Okay. Not yet. I have to write out my solution as an ordered triple. And they go in alphabetical order, X, Y, Z, right? So what's my X value? What was my Y value? And what's my Z value? Now I'm done. But you can see why it takes a while, right? But again, I hope this math isn't super hard. It's just time consuming and a pain in the tuchus. But that's fine. We can deal with that. So everybody all right with what I did? So you take your 3 by 3, split it apart, 1 and 2, 2 and 3. Remove the same variable from each system. It doesn't matter whether it's X, Y, or Z. Remove the same one. So when you're done, you can reform the system as a 2 by 2 system, which we know how to solve. Solve the 2 by 2 system for the two variables. Back substitute those into an original to find the third. Okay? So you guys and gals are going to walk me through this one. So set it up. What's my first move? What do I do with this 3 by 3? Yeah. Okay, so top and middle. Okay, middle and bottom. So form the systems. All right, so which variable do you want to remove? Again, doesn't matter? Okay. Least common multiple is 4, so I get a negative 4 on top, 1 on bottom. Everybody all right with that? All right, I'm going to get rid of x in the second set, too, so I'm going to go negative 3, positive 4. Everybody good? All right. Distribute like mad. Negative 4x minus 4y minus 4z equals negative 12. 4x plus 4y plus 4z equals 7. On top, on bottom, we're going to get negative 12x minus 12y minus 12z equals negative 21. 12x minus 4y plus 8z equals 20. Okay, now I add these, right? What's negative 4x plus 4x? What's negative 4y plus 4y? What's negative 4z plus 4z? So what's a cancel plus a cancel plus a cancel other than you're out at Family Feud? 0. Well, we don't know yet, right? We have to figure out the right side to figure out if it's infinitely many or no solution. So what's negative 12 plus 7? Negative 5. Okay, is this true or false? So no solution or infinitely many? And you're done. I don't care what happens out of here, right? What we're saying is that these two equations have no place where they coexist, right? There's no place where they cross. So if there's no value that can satisfy both of these equations, do I care if there's a value that satisfies these two? No, because even if it works down here, it won't work here, so will it work for the system? No, so I'm done. So any time you get variables completely canceling off in any step, stop. It's either no solution or infinitely many. Everybody good? And here's your homework. So, yep. So 3, 4, 5. Show if the ordered triple is the solution to the system. Okay, that's what we did first, right? Plug it in. Yes, no, yes, no, yes, no. 9 through 11 are 3 by 3 systems that you have to solve. 25 through 27, those are 3 by 3 systems you have to solve. So there's 6 of those. All right, so please get this copy down. Take a look at it tonight. Make sure that you are ready to go tomorrow for the homework day.